I'll start with an introduction. So thank you very much for coming to this event. So this event is brought to you by datatalks.club. So this is one of our weekly events. We have multiple events per week of different kinds. So on Tuesday, we have more technical events, technical in the sense that it's more like a workshop, a webinar with a presentation. So we will soon, next week, have a talk about serverless machine learning with AWS. And then the week after that, we will have a talk about a new service from AWS called AWS Glue Batch Data Brew. Also, we have less technical events like we have today. Usually we have them on Friday. Last week I had to cancel and move it to today, where it's more like a discussion. And yeah, it doesn't have any slides, so it's more like a conversation. And then this is something that we put as a podcast. So today we'll talk about processes for machine learning projects. And tomorrow we'll talk about building a data science team. Then we have another talk next week is about recruiting processes and how to stand out in this recruiting process as a data scientist. And for today, we will use Slido for questions. So first I'll talk about the processes, and then you can ask questions during the conversation, and then I'll spend some time answering these questions. I'll send the link now. To chat. Yeah, so please feel free to use Slido for asking your questions. And let's start. So just let me open my notes. So thanks again for joining. So today we'll talk about processes in a machine learning project. And by processes, I mean how everyone can work together in one team on the same project in order to deliver value. Last week we talked about roles in a team, and this talk is a bit related. So maybe first let's quickly recap what we talked previously. So previously we talked about roles in the team, and we talked about the product manager. The main responsibility of a product manager is making sure that the team is doing the right thing. Then in a team we have a data analyst. So the main responsibility of a data analyst is understanding the data and explaining the data. Then we have a data scientist whose focus is more on predicting than explaining, and it's more engineering than data analysts. Then we have data engineers. So data engineers focus that on making sure that both analysts and data scientists and everyone else have access to the data they need to do their analysis, to train their models, and they have tools to access it. Then we have machine learning engineers. They are working together with data scientists. They are taking what the models they build, and they make sure these models are scalable. They are put in web services. And then finally, we have SRE, site reliability engineers, or now often referred to MLOps engineers. So they are focused on reliability of the solution. They do monitoring and these kind of things. We all in a team need to work together. Let's say we have a problem we want to solve. And having a process to work is a good idea. So if we don't follow a process, project may fail. And what is worse, we first can spend a lot of time working on a project, and then it will fail, and we would invest a lot of time in this project, and it will be all in vain because this project wasn't useful. And then having a process, we can iterate faster. We can make sure that we're actually solving the right problem. We can check our assumptions, we can check our ideas, and we can kill projects that are not promising earlier and not waste a lot of time on them. So for that, there are many different methodologies for organizing machine learning projects. They are all relatively similar. And today I'll talk about one of them, which is called CRISP-DM, which stands for Cross-Industry Standard Process in Data Mining. It's a relatively old methodology. It was created by IBM in the 90s. And back then, data science was called data mining. Things were different back then, but surprisingly, the framework they developed still applies to data science projects today, with some corrections, but the general process is still valid today. And a process in CRISP-DM consists of 6 steps. 6 steps. So first step is business understanding. So we want to understand the business problem. We want to set objective. We want to really make sure that the problem we're solving is worth solving. Once we have that, we go to the next step, which is data understanding. And at this step, we analyze the data that is available, and we decide if the data is good enough or not, and if we need to get some new data. Then we have a data preparation step. So once we analyze the data, we found out if all the data we need is there. We need to transform this data in a way that it can be used for a machine learning model. Once we have that, once the data is transformed and it's in a way that is usable for a model, we go to the next step, which is modeling. And this is actually training the model, taking our favorite libraries like scikit-learn or whatever, and actually training the model. Once we train the model, we want to evaluate it. So we want to look at the results, check it, and see if the model performs according to our expectations, according to what we defined as an objective at the first business understanding step. And finally, we have a step of deployment. So if our model meets the expectations, we roll out the solution to all the users. We'll now take a closer look at all the steps and see what exactly happens at each of these steps. And to illustrate it better, we'll again use the same example we used previously on our previous conversation. And that was an example of classifying the category of a listing. So imagine that we have an online classifieds website where people come to sell things they don't need and where people come to buy things they need. So the website like Craigslist, eBay, OLX, Avito, there are many different websites like that. And imagine you have an iPhone and you want to sell this iPhone. So what you do is you go to this website, you create a listing, and people who are interested in this iPhone contact you and eventually buy this iPhone. So what we want to do is we want to help these sellers create listings faster. So for that, we want to develop a model that classifies a listing, automatically suggests a right category. So when you create an iPhone, it says, okay, this should belong to the mobile phones category. Yeah, and we work in a cross-functional team. So we work in a team that is responsible for this posting flow, for the form that users use to create listings. And we have many different team members in this team. We have a product manager, we have backend or front-end engineers, we have a data analyst, a data scientist, a data engineer, a machine learning engineer, and a site reliability engineer. So all the people we described previously all work together in this team, and they work on all the services related to this posting flow. And let's see how we can solve this problem using CRISP-DM. So the first step, as I mentioned, is business understanding step. So this is the step where we want to really understand the problem, and we want to decide if we actually want to invest our time in solving this problem. So let's say somebody comes to our team. Usually they come to a product manager and they say, okay, we have this problem. Can you please solve it for us? And typically a product manager doesn't immediately agree. They don't just say, hey, yes, we will solve it. First, they need to do some analysis to actually commit to this. So typically what they say is, okay, yeah, this sounds like a good problem to solve. Let's think about this. And then together with data analysts, they try to quantify the size of the problem. So what they need to understand here at this step is, let's say, how many users complain about this problem, to how many users this problem of automatically suggesting a listing is actually a problem. Then how many sellers cannot finish posting an item because of that. So when they cannot figure out what is the correct category, they simply stop and they leave the site. So how many users have that problem? And how many items end up in the wrong category? So we want to really have a number that explains how big the problem is before solving this, before jumping in solving this problem. And then we need to measure this. So measuring the number of users who cannot finish this process of posting can be tricky, because it's not always easy to understand why they decided to stop, to drop from posting. Was it because they couldn't select the right category, or was it because there was some other problem? So it involves talking to the user, understanding what are the difficult steps there in the posting. So doing user interviews, which is of course a good thing, but here maybe it's not so easy to use it as a number, as a metric. But then let's say we talk to a moderation team, and moderation team is somebody who looks at these listings and accepts them because they're good, or they do some corrections. So these are people who manually inspect all these listings. So we go to this team and talk to them and find out that 10% of listings actually end up in a wrong category. So now we have a number. So we know that, okay, it's actually quite big, 10%. And what we also can learn from them, that they have to spend a lot of time to actually move this items to the correct category. So these moderators go there and manually change the category, so the listings end up in the right place. And this is how we can measure the size of the problem. We can see, okay, moderators, let's say they spend on average 10 hours per week. Doing this, it means that 1/4 of their time they are spending solving this problem manually. And this is a big number, right? So we immediately can see that this problem is worth solving. And then, so we have a number, we can quantify the size of the problem, and we need to come up with some objective. So what we want to achieve. So let's say if we develop a model that automatically suggests a correct category, what do we want to see at the end? Let's say what we want to see is that we reduce the number of hours moderators spent on manually reassigning the category by 50%. So this is a perfect objective. So we can already see the size of the problem, and we see what we want to achieve. So then moderators will spend 4 hours less doing this manual work than previously, and they can focus on more important things. So the problem is important. We have a way to measure the size of this problem, and we have a way to measure the success. So we know if we are moving in the right direction or not. So we have the objective. And also during this step, what we want to do is we want to understand if machine learning is actually the right tool to solve this problem. So typically here, PM and data analysts would talk to data scientists and ask, hey, what do you think? Like, is it actually, is machine learning is the right tool for solving this problem or not? And then for this particular problem, like when they talk, data scientists would say, yes, actually machine learning can be used to suggest the right category for a listing. So at this step, so to recap, so they decide that machine learning is the right tool, then they quantify the size of the problem, and they set an objective. So they want to reduce the number of times moderators spent on manually reassigning the items by 50%. And as you can imagine, business understanding is an important step here. So we want to make sure that the problem is actually worth solving. So the time we spent on developing this model and time we spent training this model and productionizing it is worth spending. And this is an important step because often what happens is we spend time on things that are not important. And if we invest more time in understanding and quantifying the problem, then it's better. So once we have that, we have the next step, which is data understanding step. And we want to understand what kind of data we have available for us. So what we can use to solve this problem. Usually at this step, data scientists and data analysts work together. They look at the data, they see what is there, what is already available, and what kind of data is actually needed for solving this problem. So let's say for our problem, we need to know the title of the listing. So let's say for us could be iPhone, then we need the description, maybe also need images, and we need also the correct category. So when moderators took a look at the listing and they decided, okay, this listing actually belongs to the correct category, or they say, okay, it doesn't belong to the correct category. The correct category for iPhone is mobile phones. So we take a look at the data and we find out that we have information about the listing. So we have a title, the description, but access to images is difficult. And now we need to decide, okay, do we really want to now invest time into figuring out how to access images, or this information is enough? And then we can say, okay, like title and description is enough. We can also talk to the data scientist to see if it's actually possible to use this information to solve the problem, or we need something extra. Yeah, since images maybe are not crucial, a crucial part here, maybe it's actually a good idea to go without images and just use title for solving this problem. And yeah, if we have all the data in our data lake, then data engineers don't need to do anything else. But let's say if some of the data is not accessible, it needs, for example, let's say if we want to get decisions from moderators, but this data is not easily accessible, then data engineers will need to work with other team, with the moderation team, to actually make sure that the data can be used for our models. So the data is there in our data lake, and then we can easily access this data. So when we make sure that all the data we need is there, we go to the next step, which is data preparation step. And this is the step where we prepare the data. So usually the data engineer works on making sure the data is there. So they can work with the moderation team to move the data from the moderation team to our team to access it. So it involves setting up data pipelines and doing things like that. And yeah, when we're just starting with a project, it often makes sense to iterate, to move fast, to iterate quickly. So maybe the version of the pipeline that we have, that the data engineer develops, doesn't need to be great, doesn't need to be perfect. So as long as we can have a way of getting data from the other team and use it for solving our problems, it's good. The goal at this stage is to have the data we need for a model easily accessible, ideally in a single table. So we have all the features that we need. We have one column with target. So in our case, the features are title, description, and the target is the correct category. And we have, if we have that, then we go to the modeling step, the next step. And this is actually the step when we train a model. So as I said, ideally the data is prepared in such a way that we do a simple select from our database, and we have the data that we can simply put to our model and do model.fit, or maybe do a bit of extra preprocessing. Let's say in case if we have text, then what we can do is we can do things like count vectorizer or TF-IDF vectorizer. Basically, we need to do something with text in order to be able to use these things in a model. At this step, we need to define some model evaluation metric. So this is typically something like accuracy or precision or recall or F1 or AUC, like usual performance evaluation metric that we use for training a model, for evaluating models. So these are not business metrics. This is something we use internally as data scientists. And often at this step, it makes sense to first come up with a simple baseline, even before training a model, So it can be simply coming up with rules saying that if iPhone is in the title, then the category is mobile phones, and having a bunch of rules like that. Maybe this is already good enough for the first iteration. And then we can see, okay, what is the accuracy of this baseline? Yeah, if the accuracy is really bad, then maybe we need to invest a bit of time in training a slightly more complex model. Or maybe it's just like having a bunch of simple rules is enough at this step. But the important thing here is we have some sort of way of measuring it. So let's say we have accuracy, and we see that this baseline is accurate enough to actually go to the next step. And the next step is evaluation step. This is when we want to see if the model we developed previously on the previous step actually meets the objective we set. And in our example, the objective was to reduce the time moderators spent on manually adjusting the category by 50%. So what we want to see now is if the heuristic or a model we trained previously actually moves us closer to this objective, or actually it can we can meet this this objective. So what we do is we integrate the solution we developed on the previous step, and then evaluate it against a small traffic, a small part of traffic. So let's say we have all the new listings that are coming to us. We can take 5% of all this traffic of all the listings and apply the model to them and see how users react, and actually take a couple of moderators and put them on just working with this traffic, while the rest of the team works with the remaining 90% of the traffic. And then we can run it for a week or two, and then see if actually this heuristic or this solution from the previous step actually meets our expectation. We can see that our target, our business metric, like whether we reduce it by 50%, by 25%, or we didn't reduce at all. So at this step, we really evaluate our model, and we see what to do next with this. And typically there are a few possible outcomes. So one outcome, the project, the solution meets our expectations. So this is great, we just deploy it. But there are other outcomes. Then one of the outcomes is it doesn't meet the expectation, doesn't meet the expectations. And yeah, so in this case, maybe we just didn't know the problem well enough, or our model, if we first decided to go with a heuristic, it wasn't good enough, and we actually need to improve our model. And then we go there and train a better model, let's say, using this time scikit-learn and actually training a model, and then redeploying it, and again using this 5% of traffic to evaluate it. Or maybe we see that yeah, we cannot meet the objective at all, like we're not moving it at all, and then maybe it's time to say to stop working on this project and move on, do something else. And then let's say if it's not the case, if we decide that we like the project, the solution meets our expectations, we go to the next step, which is deployment. And at this step, we roll our solution to all the users. So while previously we were doing this for for part of the traffic, now we apply it to everything. And here the focus is more on engineering part of machine learning. So here we really need to make sure that our service is reliable, is scalable, and when it's hit with 100% of traffic, it is reliable. It will not die because of that. And usually machine learning engineers work on that together with site reliability engineers. So they take care of infrastructure, of all these web services, of configuring monitoring, alerting, like on making sure it's reliable. And yeah, so what happens at the end of this step is we can say that our model is in production. So it actually affects all the users of our platform, and it works reliably. And even if it's not a model, but a heuristic, we can see that it's already valuable. So if it's packaged in a web service, which is deployed, and then we can use this web service and iterate So we again can go back to the first step, which is business understanding, and we can see how much we want to improve the model. So we again have the numbers, then we can have some guess how much we want to improve these numbers, set another objective, and then iterate this time training a model. Once we have a simple model, let's say logistic regression, then we can come back to adding two images and see, okay, what do we actually need to do to be able to use images in our pipeline, in our model, and then maybe train an image classification model to make our predictions more accurate. So what we always need to keep in mind is business objective. And we, like when making these decisions, like, okay, do we want to train an image classification model? We need to see if adding this extra complexity of fetching the images from somewhere, training this deep learning model, and productionizing this deep learning model, does it really justify the complexity? So what we need to do is, we need to have a way of calculating the return on investment and see if let's say we spend a few extra week or maybe a few extra months on developing this solution, like, does it bring enough improvement over whatever we have? And if it doesn't, then we can just work on something else, because what we already have is valuable enough and it's already bringing value to our users. So yeah, in my experience, what we should do is we should start with a simple heuristic first, like a rule, a set of rules, a set of counters, something simple. Then we need to validate that this simple heuristic actually works and brings value. So we do one iteration over this process, and like the full iteration. So we end up at least with evaluating phase, and we see how it behaves and if the objective is met. And then we can start making it more complex. Let's say adding proper machine learning, adding more features, and perhaps using all these heuristics as features in a model. And after we iterated for a couple of times with a simple model, and we see that there is room for improvement, then we go with more complex models. Maybe we want to try something like NLP models, like something with deep learning for NLP or for images. Then it's the right time to do that after we already have a simple baseline working there in production. And yeah, so also what we need to do before deciding to invest in these complex models is calculating this return on investment. We need to imagine how much time we need to spend on this and how much value it will bring, and then decide, okay, does it really make sense to do that or not? And usually APM is doing that. I also wanted to talk a bit about data collection. So when I announced this event on LinkedIn, Julian Martinez wrote in comments that one of the hardest aspects in machine learning is labeling data correctly. And he also added that few people talk about this, and I think it's indeed the case. So that's why I wanted to talk a bit more about data collection process. So maybe it doesn't seem that CRISP-DM emphasizes this data collection, but it's actually one of the steps. This data understanding step includes this. It's an important part of the data understanding step. So at this step, we analyze the data that we have in the company. We see if all the data that we need is there or something is missing. Then if something is missing, we need to understand how crucial this missing part is. And if it's crucial, then we need to invest some time and money in collecting this data set. So let's say we can decide that we need to acquire a new data set somehow, maybe by investing time in building up a better infrastructure for data collection, or maybe working with some third-party provider to get the data labeled. And tracking the quality of data is important. So this is also what happens at this step, at the data understanding step. Often we need, usually data analysts do that. They look at the quality of data and then they see if it's actually possible to make any sensible model from this data. Like, is this data good? Will our model be accurate if we train it on our data? And what often happens here is we just manually look at this data and see if it's correct or not. And if it's not correct, maybe we should do something here. One trick that I know to check if data is not correct and actually finding the cases that are not correct is we can train a model and then apply this model again on the training set. And when we do this, sometimes models will make a mistake. And these mistakes, this is usually models make mistakes because the data is not correct. So then we can see where the model is making mistakes and then go and manually fix this in our training data. Yes, this is all I prepared for today. And if you have any questions, you have the link to Slido in chat. So let me share it again. And now I'll share my screen and open Slido. So Vladimir is asking, isn't it better to check the relationship between business metric and data science metric before modeling rather than doing A/B testing in the end? It is indeed the case, so one thing you can do that, of course, but let's say if you don't have any model at all and you just want to start doing something. So there's nothing you can do there except rolling out a simple thing to test how users react to this and if business metrics are moving. But then, of course, when you already have a model and you want to improve it, then at some point it makes sense to do something like what Vladimir is suggesting. So basically, let's say if we have a recommender system, and then we train this recommender system, and we see that the predictive performance of this recommender system in terms of some metric, let's say mean average precision, is, I don't know, 60%. And then we can try to see to link this 60% to a business metric and see, okay, 60% mean average precision usually means this kind of, let's say, engagement from the users, like as a business metric. And this is indeed possible, but we need to have already a running model for that. I hope I answered the question. So if you want to ask questions, so go to slido.com or use this QR code and then put DTC in the event in the code. Well, if you have some questions later, it's you can always ask them in Slack. Yeah, I guess if no one has any questions right now, we can. Oh, okay. Yeah, thanks, Vladimir. So Vladimir is asking, is CRISP-DM used in smaller teams? I think the size of a team doesn't really matter, and you don't have to follow CRISP-DM by letter, so you can adjust it, of course, by your needs. And then, yeah, if you think that some things maybe you want to have a special step dedicated to data collection, you, of course, you can include this in your process. And there are also many other methodologies like CRISP-DM. You can just, if you Google for machine learning processes, you'll find many of them. I think all of them are similar to CRISP-DM. And yeah, I don't think the size of a team really matters here. But having a process is always a good idea, especially having this business understanding step, because you don't want to spend a lot of time on solving a problem that is not important. And then I think a really good thing in all these processes, especially in TSDM, is emphasis on this business understanding step. Do we contact you via Slack? Thanks. Yes, of course, you can contact via Slack. That's probably the best way. Yeah, thanks for coming. So I'll make this video available on YouTube. I will also put it on Anchor as a podcast. And thanks for coming. And tomorrow we will have another podcast. We will talk with Datran about building data science team. So it's tomorrow at 12 o'clock European time. See you. Thanks for coming. Goodbye.